Good morning students. So in this class we are going to discuss about phasor and phasor diagram. So phasor is a rotating vector. So the sinusoidal alternating voltage or current is represented by a vector which rotates through the origin in anticlockwise direction at constant angular velocity omega. So the rotating vector is called phasor. So the length of the line segment. So the length of the line, the OA is a vector, that is phasor. The length of the line segment should be equal to the maximum value, that is peak value of alternating voltage or current. Then the angular velocity, so it rotates in angular, that is anti-clockwise direction. So the angular velocity is equal to the angular frequency of alternating voltage or current. Then the projection of phasor of any vertical axis gives the instantaneous values. So the projection, so it projects in this direction, it gives the value of that alternating voltage at that instant. Then the phase angle, so the angle between phasor, so the angle between phasor and the reference axis, that is x-axis, that gives the phase of the alternating current or voltage. So these are the four conditions should be maintained. So while drawing the phasor. So phasor diagram, so it contains various phases and phase angles, so phase relations between voltage and current. Here, so consider an alternating voltage. So it is represented by a phasor, that is a rotating vector. So it rotates from 0 to that angle, that is omega t. So it shows some voltage, so at that instant. So it rotates in angular velocity omega, that is the angular frequency of alternating voltage or current. So it rotates in circular. So at initial position here, so that is 0. Again it rotates through 90 degree, 180 degree, 270 degree. Again it rotates 360 degree. So it rotates in a circle, that is like that. So the length of the line segment should be the peak value, that is line segment peak value. So 0 to pi by 2, 0.3 pi by 2, 2 pi, that resembles that alternating voltage, that is sinusoidal alternating voltage or current. So 0 to pi, that is rotation, it gives the value. Again pi, 3 pi by 2 and 2 pi. So this is a phase relation. So it rotates. So at first it is in the first quadrant. So the circle is 4 quadrant. So first quadrant, what is the value? Again it rotates, rotates, rotates. So at this instant, what is the value? At this instant, what is the value? At this instant, what is the maximum value? Again it rotates that anti-clockwise direction in second quadrant. So it resembles that pi 2, that is pi by 2 to pi, that is second quadrant. Then again it rotates. So again pi to 3 pi by 2. Again it rotates. So again 3 pi by 2 to 2 pi. So that is the working principle of phasor. So now the alternating voltage. So in the same circuit the alternating current is flowing. So the current flows like that. So this is the current, then this is the voltage. So V versus omega t curve. So we are going to draw that phasor. So phasor OA represents the voltage, that is alternating voltage. Then OB represents the alternating current. So that OA represents the voltage at that instant. So that is, so it rotates from, so it's omega t from 0 to it's omega t like that. Again the current, so what is the relation between, that is what is the phase angle between voltage and current? So current initially, now the OB vector represents the, what is the current at that instant. So if we compare, current leads voltage by pi. So the current leads voltage by pi. So that is the current, that value Im sin omega t plus pi. So if it is current in this direction, so the current, that is we can represent C. So it's lags behind. So voltage current lags behind pi. That means you can write it as Im sin omega t minus pi, that is OB equal to Im. So this is a phase relation. Just see from the origin, so current starts. So it's a sine angle, that is voltage. Then current starts initially its maximum. So there is a leading. So the voltage and current leads by pi. So just see initially it makes, there is a difference. So initial the voltage is 0 but current is some value. So there is a difference, there is a phase difference between the current and voltage. Using the phase diagram we can find. So in this class we have discussed what is my phasor. So phasor is a rotating angle, that is rotating vector. So it represents a sinusoidal alternating voltage or current which rotates in anticlockwise direction with the angular velocity omega. So the length of the line segment is the length of the phasor. Then phasor rotates in anticlockwise direction. So at that instant, what is the value of voltage or current is represented. So one complete circle, that is one complete rotation gives the one complete cycle of alternating voltage or current. So from the phasor diagram we can relate the current and voltage. So what is the relationship? The current leads voltage by pi, that is omega t plus pi. So if it is current lags behind the voltage by pi means omega t minus pi. So here minus pi, so plus pi. So